Great. Welcome. I am Francesca Dominici, and together with David Parks, I am a faculty co-director of the Harvard Data Science Initiative. It is such a pleasure to see you all today for our very first of this year Harvard Data Science Initiative industry seminars. These seminars provide an opportunity for the Harvard community to hear directly from industry data scientists about the role of data science plays in the organization, the methods and the techniques being used, and their own career trajectory. Today, we are joined by two colleagues from Elsevier. Elsevier was one of the first donors to the Harvard Data Science Initiative, and for that, we are very grateful for their involvement. They have also taken part in our corporate members program and spent time with us. They are thinking about the universal data science issues that affect many industries and sectors. Brad Hallen is chief architect and leads the architectural governance of Elsevier, guides Elsevier Labs collaborative research into the future of scientific and medical publishing, and chairs Elsevier's data science leadership group. Prior to Elsevier, Brad was founder and CTO at a series of enterprise software startups in the Los Angeles area, beginning his career as one of the first knowledge engineers of the expert system area of artificial intelligence application. He has a BS in applied mathematics from Carnegie Mellon University. Also joining us today is Daniel Kershaw. Daniel is a senior data scientist at Elsevier. He completed his PhD at Lancaster University in the prediction of information diffusion in online social networks. And at Elsevier, he has worked on and delivered numerous machine learning for personalized information discovery for Mendeley and Science Direct. Currently, his focus is on automated text summarization and knowledge graph construction for personalized information consumption and discovery. After Brad and Dan present, my colleague, Jennifer Chow, will moderate a Q&A session. Please feel free to ask questions using our Zoom Q&A function as they occur to you during the talk, and Jen will ask them of our speakers at the end. Brad and Dan, thank you for being here. The floor is yours.
Well, thank you very much, Francesca. Very much appreciated, and we really value the opportunity to come and speak at the industry seminar. As some of you know, this is something that we had hoped to do in March, and events transpired to prevent that, and very, very happy to come back and kick off the fall session with this talk. So what I wanted to do, as Francesca described, talk a little bit at first about why data science is as critical to Elsevier's future as we feel it is as an internal team. Talk a little bit about the motivations, what our data science organization looks like, the principles we're using, and the technologies we're bringing to play at a very high level. And then I'm going to hand it off to Daniel, who is a senior data scientist in our group, is really working on a lot of very specific problems in applying the technology to challenges we have in delivering value to customers. He's going to go into much more detail with a number of examples. But I would be remiss if I didn't mention, we'll be covering a lot of kind of the groundwork that we're laying to allow data science to happen across the company. And Daniel will get into some examples relevant to our research side. We have also a presentation by my colleagues, Kaushik Raha and Connie Villalba, coming up on November 5th for the industry seminar, which will dive into a great deal of detail on what we're doing to support medical decision-making. So I'll touch on that. But we wanted to kind of give an overview about data science at Elsevier and talk a little bit as a point of departure into further discussion. So Elsevier is a company that, you know, as many companies are in today's economy, you know, dealing with the impact of the emergence of the internet as the primary method for sharing and communicating information, particularly as it relates to the information required and used and produced by scientists and medical professionals. And we see that as something that, you know, started back in the late 90s. In 1995, there was an article in Forbes magazine about how Elsevier in particular and scientific publishers in general would soon be swept aside by the emergence of different ways of delivering information and communicating scientific results. That hasn't happened, and there are a raft of reasons, I think, that we could get into about why that is the case. But it's become clear that simply moving content publishing from, you know, its original sort of print-centric model to a delivery of content online and then the delivery of information outside of the context of the traditional containers, which were very much based in, you know, the print era. That change is something that is really critical for the company to be able to navigate moving forward. And so you can think about that as a progression from a focus based on our tradition as a publisher on producing materials in traditional formats for scientific professionals and medical professionals to read. You know, so journals like Cell, reference materials, teaching materials like Gray's Anatomy, that was the bread and butter of our business for a long time and continues to be so moving forward. But with the transition at, you know, in around the 2000 timeframe to a truly internet-based instantiation of how we could deliver and produce that information, it became clear that we needed to add to that the ability to have effective discovery tools for researchers and professionals over that information for them to be able to use not only for real-time decision-making, but for their learning and understanding of the various areas in which they're engaged in doing their research. So search in particular as a capability became very important. Products like Science Direct, Scopus, Clinical Key, our chemical information product Reaxis became, you know, focused on delivering the best capability that we could to our customers in that vein. But as we've progressed through the last decade and a half, increasingly we find ourselves really trying to grapple with the issue of delivering information in a just-in-time basis with relevance to the particular context that the decision maker is involved and engaged in, and giving them much more focused, pointed information that is pushed to them as well as pulled by them through traditional search and discovery mechanisms. So more recently, we've been developing applications such as SurePath, Novel, Clinical Path, and Mendeley, which are really focused on how do we provide guidance to people in the context of their day-to-day job as scientific and medical professionals for them to be able to effectively, you know, do the best that they can in doing what they do. The company views itself as really addressing 5 main customer segments. On the medical end, clinicians, people who are making decisions about treatments for patients, trying to understand how to apply the best of medical knowledge as is available to them through the literature, through their own experience, to improve the outcomes for the patients under their care. And the typical kind of thing that we want to be able to present for them is to really give them the insight to get the best kind of treatment for a patient that they're considering and improve their outcome to the greatest degree possible. For researchers in general, you know, part of the challenge is really understanding in a full spectrum way what is relevant to their interests and make it easy for them to be able to gain access to that and read it and understand it and work with that material. And beyond that, we also engage with governments, or essentially funders for scientific research, you know, giving them information based on signals out of the citation graph, the general structure of the social network of science about who they need to consider as or what they need to consider as they invest in research, through the various funding mechanisms that they have. From a more commercial perspective, another important segment for us are pharmaceutical companies, essentially giving life sciences researchers in the commercial context access to the same tools that we provide to researchers in general for life science domains, but give them the ability to work with our content and data and their data to be able to really understand where they should be placing their bets as it comes to processes like drug discovery and the like. And then finally, we have a significant segment in health professional and nursing education, essentially allowing people to understand, as they go through courses, preparing them for certification exams, where they're weak, where they're strong, what remediation, they can take in terms of course material or other kinds of content to be able to allow them to improve to the point where they're capable of passing their certification exams with flying colors. So these are the people we're trying to address, these particular constituencies. And across them, there are a number of challenges that are significant. A good thing is that from a global perspective, research spend is growing, on the order of 3.4% a year. But that's creating challenges with regard to issues of discovery, in the sense that with that increase in spend is an increase in the production of scientific content. And the issues associated with making sure that the right research finds the right eyeballs is a challenge in terms of the volume, the quality control issue, the ability for us to disseminate and deliver. And that's just putting a lot of stress on the scholarly communication ecosystem as it stands today. We acknowledge the fact that from a research context, a lot of what we do is provide the ability for researchers to disseminate information and make their work reproducible. And as I'm sure a lot of folks on the call are aware, there are real challenges with regard to doing that, particularly in the way that information has traditionally been communicated as, heavily groomed, polished, peer-reviewed articles, as opposed to articles with data sets, with capture, with the ability to capture the computational context in which that data is worked. There's an issue there that is critical to us with regard to reproducibility. On the life sciences commercial end, making drugs is hard and it is expensive, and the success rate is low. And the challenges that we have with regard to getting people in a position to make the right decisions there could have tremendous impact on the commercial performance of the organizations that rely on the content and data that people like us produce. And then finally, this is from a study that is somewhat controversial, numbers from the World Health Organization, but also, I believe, published online. If you look at preventable medical errors and categorizing them, that is possibly the third largest cause of death in the United States. That's an issue that is heavily dependent on people's ability to get the right information at the right time in a way which is of the highest quality, given the context that they're providing medical care in. So all of these things are important to one or another of the constituencies that we're trying to address. And that's where we see data science as having a tremendous impact. Our role traditionally has been as a publisher, but increasingly it is as a vendor of data science solutions, of decision support solutions that we're providing as services to professionals. One of the perspectives that we have there is that we don't see the ability to build a model as something that allows us to replace professional judgment. What we want to be able to do is craft and deliver these kinds of capabilities in ways that augment human professional decision-making as opposed to replacing it. The bottom line is to provide better outcomes for the various constituencies that I've just mentioned, and do that, by just-in-time delivery of context-sensitive information in the context of the tasks that researchers and medical professionals are doing day to day, and then providing discovery and increasingly query capabilities over structured information derived from our content, over the information that we have to provide the way for researchers to get a better handle on what's happening in their disciplines, both in terms of how science is being done, as well as the science in and of itself, and to answer the kinds of research questions using the literature and relevant data that they're trying to accomplish as they further their careers. So let me talk a little bit about our data science community and how it sees itself working. All told, Elsevier has about 7,500 employees globally, and you can see the distribution on the right-hand side of this chart is, in the U.S., in the EU, and increasingly in Asia. Heavy footprints in China and in India. The data science community is part of our technology group, which is about 2,000 out of the 7,500 employees. About close to 8 to 10% of that technology community are data scientists, as we define that term. They are mainly in Amsterdam, London, and Philadelphia office. Amsterdam and London deal with our research products business. Philadelphia deals with the healthcare business. And they are leading the charge with regard to the use of data science and improving our products and our services. In addition, it's worth mentioning that part of the Elsevier organization is one of the things that we have as a strength is that we have many subject matter experts who have been researchers or medical professionals in the past who are part of our team and providing significant subject matter expertise that augments the data science team in terms of their ability to understand how to map from customer use cases to the various solutions we're providing. We've adopted a number of principles that I'm showing here on this chart that we see as being important to how we do data science as a general thing, but specifically with regard to data science at Elsevier. And I think that this is an important thing that I want to share as part of this discussion is that there are some things that are unique for us. But first and foremost, it's about working backwards from the real customer needs. Understanding what questions are being asked by the customers, what their specific requests will be, and then framing that as a data problem. Do we have the data to answer that particular kind of question? If we don't, what data do we need? If we don't have that data that we need, where do we get it from? How does it need to be transformed? How does it need to be integrated with the data and content that we have at hand? It's all about working backwards from the customer use cases. The thing that I think is specific to Elsevier is that we have this decades-long legacy of just producing as high quality content for the scientific community as we can possibly manage. And that traditionally has been captured in the main mechanisms that people have been using to publish in journals or publish reference works as books. There's a lot of opportunity to leverage that legacy in the context of building data solutions. And we're very, very much focused on how do we translate a lot of the best practice that we've developed around getting best in class quality in our content into doing that for data as well. And so we want to be able to leverage our unique strengths, particularly with regard to that focus on quality. To that end, dealing with the challenges of data acquisition and quality first, as I'm sure it's not a surprise to anybody in this community that we're talking to here, most of the work in doing data science is unfortunately getting a hand on the data and turning that data into some kind of representation that you can work with effectively. Increasingly, we're dealing with that in a way where we're very conscious up front with regard to the issues associated with bias, fairness, privacy, and more recently, the risks associated with the perceived challenges of automation through AI in automating some of the impact in the negative sense of this kind of a thing. That's a very important thing for us to deal with first, data quality and data acquisition. Because of the fact that we see data science as producing solutions that augment decision-making, as opposed to simply automating away human touch. Human in the loop by default is an important design principle for us. Trying to solve problems in a way which are manageable as opposed to requiring us to boil the ocean is another consideration. And then finally, as a principle, really beginning to invest in relevant open problems that we think could kind of advance our ability to extract as much structured information from our content to make it malleable in a way that allow us to build the kinds of applications that we are delivering to our customers, and to do that in a way which, effectively teams people and machines together. All of those things, have a lot of elements of open problems. The data science initiative here at Harvard is working a lot of those kinds of issues, and we see ourselves collaborating with that. But we know that that's something we need to focus on, and Daniel will touch a little bit on what we're doing specifically there as we get further into the talk. We're beginning to see over the last few years real impact in the business of the application of data science across the various kinds of business and customer bases we're serving. This is a question and the responses from that question for an internal survey that we conducted towards the end of last year in terms of where the data science community sees themselves as having had significant business impact. By and large, you can see, just to kind of reading it off, the three top things are, an improved user experience, particularly as it relates to discovery and access to information, the ability to innovate new products, and then the issue of improved data quality. Growing revenue streams, creating new revenue streams is an important component of that, but top of mind for the data science community is this issue of better UX and innovation in terms of product and improved quality in which we're using to build those products. Let me talk a little bit about what we think of as our core data sources. Again, one of the things that distinguishes us from a number of other enterprises is, again, decades-long emphasis on the curation and the production of content that captures the best of what science and medicine is producing in terms of research. Those things have traditionally been captured as books, journal articles, things in the medical literature that are specific to medical decision-making, like guidelines. We have a tremendous wealth of that information built up. Increasingly, we're going, not just to the stuff that we publish, but the things that are also, available through open access out on the web in general. But it's about content as a conveyor and container of scientific knowledge and expertise. And the challenge, one of the most significant challenges we have is how do you break out that knowledge in a way where we can structure it in a manner to serve our ability to do data science and create data solutions effectively. But it's a key, important integrating component in everything that we're delivering as product. There's data derived from that content, some of which we've been doing for a long time. For example, extracting citation data, organizational profiles, author profiles, and the like, but increasingly going in and wringing out of the content, different kinds of sources of information we haven't necessarily emphasized in the past. For example, really understanding how projects are being funded as it's revealed in the acknowledgments in the literature, and being able to kind of structure information that has a much better understanding of that aspect of the social network of science. There's an addition to this data derived from the usage of our products. So, in a more general sense, the sorts of things that we get as people come in and interact with our applications, article views, access statistics, all of that provides additional signal for us to understand what people are engaging in with the information we're providing, to express interest, to express trends, and the like. And then finally, an increasing amount, as I mentioned earlier, with regard to content, but also with data, is working with third parties, working with the results of open science and open access to broaden the scope of information that we're providing. And there's a there's a scientific research aspect to this, but there's also the issue associated with on our healthcare business, integrating with data from our partners, from customers of healthcare services that Kaushik and Connie in their talk on November 5th will get into in great detail, but it's beginning to expand further the notion of the type of data and the care in which we need to manage data to be in compliance with regulatory concerns and with the ethical considerations associated with dealing with things like patient health data. This is really just basically a characterization of the set of capabilities we're focused on in terms of building support for our data science community so that it becomes easy and, most importantly, a self-service kind of capability that we're providing for them to be able to work with this progression from how are we getting the data and query specifications in to describe the sort of thing we need, how are we acquiring the data, and then linking it, which is an important aspect, particularly as it relates to building the citation graph and this general social network of science information we're capturing. Enhancing that data, creating mappings to standard ontologies, taxonomies, and vocabularies, and then deploying that typically in a graph structured format for our development teams to be able to then deliver as services through APIs, through user experiences and the like. All of this is a set of all of these are capabilities that we've worked on very hard over the last 5 to 10 years to make general across the various teams that are trying to do data science and get us to the point where we can begin to achieve a vision that I'll talk to you a little bit now about that we see emerging in the work that we're doing at Elsevier over the next 5 to 10 years. And that is really about building a general data platform for outcome improving insights. So this diagram is a little busy, and I apologize for that, but it really basically serves to show how we're tying all of this together, taking those capabilities and arranging it in a flow where we're working initially with authors who are trying to help publish their work so that they can be recognized, and viewing that as a kind of a decision support context as well. What journal should I be submitting to? What can you tell me about the metadata that I should provide with this article to make it as discoverable as possible? Bringing that into a set of data and content repositories that data scientists can work with to be able to analyze that data to uncover the value, but then developers can work with to be able to package that up, productionize the data flows and models that data scientists are prototyping, and then deliver that in the way of packaged insights to these different constituencies. And typically, if we carve out the focus on life sciences and nursing students that I talked about in the initial part of this presentation, it's really about helping institutional leaders evaluate, plan, and compete in their areas of expertise in an institution, helping researchers stay on top of their field, and helping medical practitioners achieve good patient outcomes. This kind of breaks that down in more detail. And so the challenge here is, how do you build this kind of platform on top of the legacy infrastructure that has been primarily built to deliver content in a traditional printed form, either as PDF or as XML and the like? And that's the kind of challenge we're working initially by also considering this in the broader context of what is the data model of science and its kind of social network. And so this is really kind of a view into the key entities that we're building systems to, extract out of the content and data that we have, the various kinds of relationships and attributes that those entities have, and build that in a way where what we can't do easily today is then much more easily approachable, which is not worrying about, in essence, the silo associated with a given product that's been built for a specific use case, but really treating the data as a completely integrated view over all of the content and information that we have, that we can splice together, slice and dice, and then use to build very specific applications that may unite things in ways that we really haven't integrated before. One of the challenges that we have here is doing this, building this kind of platform vision up in a bottom-up way. We currently have within our research products group, our life sciences group, and our healthcare group, 3 separate efforts to build data platforms that are focused on supporting the various kinds of customer use cases that they have. And one of the challenges that I have in my position as chief architect is to work through the issues of how do we share that effort? How do we govern that in a way so that it all comes together in the long run as something that looks like a single integrated platform as opposed to 3 or more different kinds of platforms. And so that's all about making sure that we have a common approach, which is inspired by the standards associated with linked data and the open linked data cloud. The common vocabularies, leveraging ontologies and taxonomies that have been expressed in the wild, as well as ones that we've innovated and created ourselves, and then creating a basis for sharing components and services that deliver that across a wide range of different types of assets that we're responsible for producing as part of building out these platforms. So that's something that we're in the process of working on. That the data science community is very much engaged in helping drive these things, particularly as it relates to servicing the various kinds of use cases that we have today. So what I want to do now is talk a little bit more, or have us talk a little bit more detail about what specifically we're doing as we're building out those platforms, as we're kind of taking this approach to delivering value to the customer. I'm going to hand it off to my colleague Daniel to talk a little bit about how we think about those data science efforts that we're engaged in, and then get into some specific examples. So Daniel, take it away, and then cue me and I'll advance the slides.
Thank you, Brad. Thank you for having us. So I'm going to focus on the sort of practical applications of data science and how we do it. And we're going to first break down data science and machine learning activities at Elsevier into 3 broad categories. We have our business as usual class, Roofshots, and Moonshots. Business as usual focuses on the currently deployed systems which are currently being used by our customers every day. These are our ML solutions for knowledge discovery, our knowledge delivery solutions, and also quite a few examples of our entity and relationship extraction systems. Our Roofshots are our short to mid-term ranges. These, as Brad said, are generally about sort of more infrastructure, more the platform, about how we sort of automate the long-term deployment of machine learning solutions. And you can see this in a lot of our human in the loop and NLP pipelines, where it takes a number of different iterations to get to the end point. And then our moonshots, these are our long-term solutions, which we know will be really promising, may not be in a product at the moment, but we have people working on them to try and answer the challenging solutions. These are generally around our sort of multitask learning architectures, but also focusing on large-scale language models and question and answering systems, which I'll touch on at the end. So first of all, I'm going to focus on business as usual. So if you want to move the, brilliant. So this is a project which I've been working on for the past 18 months. And it focuses around automatic summarization of scientific articles. As I'm sure we're all aware, the amount of research that we have to read on a weekly basis to keep up to date with is sometimes overwhelming. And looking at a paper which can be on the range of sort of 20 pages can sometimes seem a bit daunting, especially when you're just wanting to understand whether it fits what you're looking for. So this is where we've come up with solutions to try and show the correct bit of information to the user at the moment they need it. And we do this through an automatic summarization system. And particularly we do this in an extractive way. So this is so when we talk about summarization, we talk about 2 distinct classes, extractive and abstractive. Abstractive is where we rewrite the document and come up with a concise, human readable paragraph that summarizes the document. Whereas extractive, which we focus on, focuses on selecting the sentences which summarize collectively the document in its whole. And we chose extractive mainly because we believe the authors of the paper are the best people to write the paper. And the tool we're developing is to try and draw the user's attention or the reader's attention to these sentences and the core bits of information quicker. And this is to improve reading time and able to improve the sort of the time to understanding for the user. We additionally use this in sort of a few of our indexing services and looking at sort of how it can be used to improve our search solutions. So if we go to the next slide. So when we're talking about selecting the best sentences in a document, we need to know, first of all, from a training data set, what are the best sentences? And this is a challenge which we came across. And one could have a solution where because we have a lot of subject matter experts within Elsevier, and we could have sent out papers to them, got them to annotate them about where the correct sentences are. However, this is, if you gauge that someone takes about 30 minutes to read a paper, and we need probably a training data set size of a few thousand, and probably would want inter-annotative agreements. This would be both a very time constrained thing to do, where we would take ages to get this data sets together, but also potentially very costly. So for this, we looked around, and about 25% of our recently published articles have these things called author highlights. Author highlights are a more concise set of bullet points that summarize a paper more concisely than an abstract. And there are usually about 4 to 6 of them. And when these are submitted by the author at the time of publication, and they're designed to highlight the core findings of the paper. So not necessarily the abstract, which, depending on which field you're in, is there to sell or sort of lay out in a form about what the paper's about, but to basically tell you what the findings and the key points of the paper are. So we thought this would be a good way of starting. And the idea which we came up with was, can we select sentences within the document which are like the author highlights? And to do this, we use a metric, which I presume some of you will have heard of Rouge. So this is a metric called the recall-orientated understudy for Geist evaluation. And there's multiple different forms of this. And we focus on Rouge LF. So this is basically taking a target and a sentence. How much overlap is there between them? So for this, we chose the LF version because we wanted the longest common denominator within the sentence and the target. And we also wanted sort of the harmonic mean. So there's a precision version where we're looking at how much of the target has been captured, and a recall version, which is how much of the candidate is there. So we wanted an average because one has a very short result and one has a very long result. So we've used this as a metric to go and select the sentences within the document. But we don't do this one by one. We do this in a greedy way. So we go and select the best sentence, which is like the highlights. Then we go and select the second best sentence, which contributes the most to the overall score. And we keep doing this until we have, until there is no further increase in the Rouge score of the set of sentences within the document. And then this gives us the positive examples from within the documents which best summarize or are most similar to the author submitted highlights. Next. If you, Brad, yeah. So then we have an example here. So we have the author highlights talking about bioactivity guided cut for CC strategy was designed. And we can see here that the 6 top selected highlights are talking about CC cutting. They're talking about LSD1 inhibitors. So you can start seeing it is selecting descriptive sentences about the results and findings within the paper. If we go to the next one. So then how do we use this to develop a model? So the idea behind the model is, can we select automatically the sentences within the document which best summarize the findings and the results according to the author of the paper. So the diagram I have here is of the second iteration of the model, but the first model we tried was basically a binary classifier on each sentence independent of each other. So we'd go through each individual sentence and use an LSTM or a form of binary classifier and try and classify each sentence as, is it a summary sentence or not? We use additional features within that model, such as section labels, number of numbers, and a few other ones, and it produced good results. However, because it was a binary classifier, there was no context around it. So you'd end up with sort of very similar sentences being selected, and you'd have to do sort of a manual mix of the sentences afterwards. So we thought moving from a binary classification problem to a sequence classification problem was a more appropriate solution for this, because a document is a sequence of sentences, and they aren't just sentences which have been randomly put together. There is a purpose there in that order, and there's a purpose they should be read in that order. So we wanted to capture the context of which the sentences were in within the document. So this is where we came up with this, started using this model. So it can be broken into two distinct components. So we have at the bottom rectangle is the sentence encoder, where each sentence is encoded using one of three methods. This is either an RNN with an LSTM inside it, a CNN, or a mean embedding, because each sentence is represented as a sequence of word embeddings. So for the mean embedding, this is where we just basically take the average of the average of the embeddings. This is fast, but it can sometimes be a bit sort of basic. It can be sort of put a sentence in a very arbitrary space with no particular meaning. CNNs, we use a one-dimensional CNN across the word embeddings. And the benefit of this is that it can capture bigrams and trigrams depending on the number of filters you put on it. And it is fast because it can be parallelized on GPUs. And then we have RNNs with LSTMs. These are slower because it's a bit more challenging to parallelize them on LSTMs. However, they do capture, depending on many layers, sort of dependencies across boundaries within the sentence, which may not be captured in the CNN, but they're particularly slow to train. Once we have these sentence embeddings, these are then fed into a sentence extractor layer. This is basically the context layer for the document. So we pass it to a bidirectional dynamic LSTM with a hidden layer and do a number of passes. And the idea behind this is that we want to capture contextual information in the sentences before and after. This is why we use a bidirectional one. The output of these hidden layers within the LSTMs are then used as the final representation for each sentence, which should be the combination of its individual sentence embedding and then some contextual information from the structure of the document. These are then passed out to, for this diagram, this is a multi-target learning, multi-objective learning model, both a section classification task and a summary classification task. So for the section classification, this is basically predicting what section is this from. And then the summary is basically from the previous slides where I discussed the summary, the labels we've given the sentence, predicting whether it's a summary or not. And when this goes through multiple layers of dense layers to a final softmax classification. For the summary classification, we've also introduced a sort of dependency between the classifications of the previous ones. So this is quite I would say quite a simple model. It's also quite a lot of parameters that need tuning. So you have everything that needs tuning from selecting from what sort of word embeddings you're going to be using to what settings within the CNNs or LSTMs you're going to use and the number of RNN layers you're going to use. So this is quite a challenge. So we need systems to automatically go and select the correct parameters, but it is a model which is quite simple. So this is something I personally try and do within my work at Elsevier, is not go for the bleeding edge. So there may be questions around why aren't we using sort of BERT or transformers with this. This model is particularly explainable and it is particularly implementable and sort of describable to people around Elsevier, and it's also maintainable from an engineering perspective. I can work with engineers, I can work with the product managers and get this into production without having to sort of get them to sort of trust me wholeheartedly that transformers the way forward, because this needs to live for a year or two without potentially my input. If we go to the next one, next slide. So training this model, how do we train it, what do we train it on, and what settings do we end up using. So for this model, we trained it on numerous different data sets, but the one I'm going to talk about here is a medium data set we used. So this was trained on 83,000 documents. There were an average of 10 positive labels per document, and on average, the documents were about 163 sentences long. So that you may be saying that's quite long, but remember we have everything. This is a data set which contains everything from long review documents in biomedical domains to quite short maths proofs. So 160 is what we would usually deem appropriate. And the LSTMs, one of the benefits of using an R and N for the context is that because they can be classified as dynamic, they can cope with up to about, we've shown on our systems about 250 to about 1,000 sentences, depending on how slow you want it to train. And on average, a sentence within each document is about 24. Again, there's variations depending on writing style and discipline. And then again, we have a test data set of 41,000 and a validation of 13. The results I will present in the next slide are based on the 13, no, go back, I'm not finished. Are based on the 13, but for the test set, because we don't want the model overfitting, we just train up to 50 epochs, but then implement early stopping based on the results of the test set. This is so we reduce overfitting on the data set. And through doing our different experimentations, we revealed that we found that glove embeddings were good enough to start with, because modification of the embeddings through training resulted in good enough results, and embeddings of about 100 were optimum. And again, we could have gone for larger embeddings or larger hidden states, because our hidden states in the LSTMs are generally only about 120, because it's a payoff between speed of training, cost of training the models, and the results you get out of it. A marginal increase by increasing either number of steps or embedding size or hidden states isn't really potentially worth that much, because we can get something out quicker if we go a bit smaller and get more results faster. And again, because we're talking about sort of this in production environments, the technology we choose is quite, it may not be, again, bleeding edge. So for this, we use TensorFlow, and we have just upgraded to TensorFlow 2.1 from TensorFlow 1.5, and then at the same time upgraded to Keras. Again, this is for maintainability, because everything has to be maintained in the long term. We deploy this on SageMaker, again, a managed environment where we can monitor all the different variables we want and have people access who aren't me, all the different parameters, and see what's going on. And it's all on AWS. For the heavy lifting, because I'm sure you're aware, 83,000 documents isn't a particularly small amount of data, and especially when we start going onto more larger scale production data sets where we roll this out on 250,000 documents at a time, we need something which can be parallelized across a cluster of machines in a maintainable and assured way, again, which can be managed by engineering teams. So from this, we stick to a set of tools which are well maintained and understood by our group of engineers. If we go to the next slide. So numeric results. I'm going to talk about numeric results first, then we're going to look at some results and then go on to an example of this in production. So these results are from a paper which we have written around this model. And we can see here that the different sort of embeddings. So first of all, we look at the top left corner. We can see the different sentence embedders, sentence encoders, along with whether the word embeddings used have been able to be updated or not through backpropagation. The results then are broken down into individual disciplines. This is so that we can understand how the model is applying to different disciplines. Because Elsevier is predominantly a life sciences, we don't want to ignore all the different disciplines we have within our journal remits. So biology, you can see here, what's a Rouge LF of 4, it's 21. So this was, compared to some of our baselines, this was particularly good. And we can see these results maintaining across the different disciplines. And it's similar when we look at the value of it, the Rouge scores across all disciplines. We also train models multiple times so that we are confident that what we're getting are statistically significant results and not due to just a random initialization of embeddings. Also, because we introduced a context layer within the model, we wanted to understand what addition does the context of the sentence or the location of the sentence in the document have to the quality of the summaries we produce. So we trained the model on the same data set, but instead of having the sentences in one particular order, we randomly shuffled them. Then on the validation set, just pass through the sentences as they are. And this is to test whether the data set, the structure of the document has an influence on the quality of the summaries. So as you can see here, that the structure of the document does have a marginal effect on the sentences, because when we look at the results which aren't shuffled, we can see that there is about a 1% improvement in the quality. However, numbers are only half the story. We want to understand what the quality of the summaries are from people who actually read them. So one of the benefits at Elsevier is that we have subject matter experts dotted around the company. So we systematically send our summaries to them, depending on their discipline, and ask them to rate them based on a 4-point scale across 4 dimensions. So we ask them to rate the summaries based on the diversity of sentences selected, because we don't want loads of the same information. The informativeness, is it giving you the correct information you want? Simplicity, are they selecting just sentences with loads of citations in? And the relevantness. So again, here you can see across the board that they are sort of above what we'd classify as a random baseline of about 2.5. And at the same time, we randomly inject actual author highlights, the ones the author submitted. And you can see that you can see that the author highlights are higher than the summaries, but not significantly higher, which is a good indication that what we are selecting is not too bad a summary, which is a quite nice thing. So if we go to the next slide. And when we look at the actual summaries which are produced, you end up seeing some interesting results. So on the left, you have the author provided highlights, sort of talking about mRNA, the decrease with increasing age and silky flow, and fats and visceral fats. And the extractions which we have selected are surprisingly similar. And this is a trend that we see amongst our authors, where the highlights that they have selected are taken from sentences within the document themselves. When we first saw these results and such a large overlap between the author highlights and the extractions which we had selected, we believed that we had a leak in our data set. So we went and looked at the training data and realized we didn't have any data leaks between our test, train, or validation data sets. So this is a really good indication that what we are selecting is what the authors would have selected themselves. So we see this as a good validation. But just looking at this is only half the story. So we want to get this out into the product. So how do we get this into the product and get user feedback on actual people using it? Next slide. So this is where we put the highlights. So we put them on the enhanced reader, which is within Science Direct. And you can see here that they're put on the top right corner, but they're not showing all of them completely. Recommendations, unlike recommendations, which have a call to action because the user is going to click on them and that's deemed as a positive signal. They add it to their library or download, that's an even better signal. Summaries, how do you get a user to interact with them and give feedback? So we put them in the top right corner. We don't show all of the information and give them a show more button for them to click. So if they click it, and click, it expands it, and then after 10 seconds, which we presume would be enough time for them to scan and maybe look, we ask them a questionnaire. Just to get some feedback, because we also want to know what they think about it, how we can improve it, but we also want to know if there's any errors, because we do realize that sometimes a bad summary may come across, and we want to know where these are. And the results from these surveys will get passed back to me, passed back to the team, and we can then iterate and improve on the model. It also means that product can see how it's all performing, and it's a good way of getting user interactions. If we go to the next one. But this is just one product within a complete suite of data science solutions which we have at Elsevier, which are currently in business currently classified as business as usual. We have things from Reactis, our chemical pathway data solutions, to Scopus, which is a primary, secondary content record holder. And for this, we use ML models to extract funding information, like Brad said before, to build up profiles of funding information. We then have stuff like Science Direct topic pages, which uses the content of our books and journals to generate pages which show users definitions of concepts, which can be found in common taxonomies such as Omniscience and the extensions. And this is looks at sort of giving users a navigatable solution right through our books. And then we have Mendeley, which I presume a few of you will be using. And this is some of our recommender systems. So this basically recommends users based on what they're reading, what would be the good thing to read next. And this is a widely used product. So if we go to the next one. But then what about our Roofshots? Our Roofshots are sort of 1 to 2 years. We're currently working on them, and they're multiple iterations. And the thing we're looking at the moment to sort of, as Brad was saying, to bring the different platforms together is sort of ML auditing and putting sort of a more engineering perspective on our machine learning deployments. So we have our feature developments and our model developments, which we work on, but then how do we automate the test and deployment strategies? So testing, this is focusing on sort of how do we look at the stability of the model, making sure it doesn't overfit, and how can we automate this through automatic test set creation? But then comparing the models which we're developing, how do we compare them to models which may be in production already to make sure that they don't reduce the quality of what they're doing? Can we automate the testing against test databases? Can we do counterfactual evaluation against already known systems in production to make sure the model which we are about to deploy is as good as or better than the one which is about to be deployed, and doesn't upset our users, and make sure that they are always getting the best recommendations or best machine learning predictions out of our models. So if we go to the next slide. But then what about our moonshots? Our moonshots look at sort of things which may not be in product at the moment, but are showing value. So for this, we're looking at question answering for knowledge graph construction. So as I'm sure you're all aware, through many of the NLP conferences, the rate at which language models are developing is phenomenal. And how can we use these and utilize these to develop solutions within Elsevier? So for this, we're particularly looking at question and answering systems. So question and answering systems traditionally use sort of, the use case that people talk about them is potentially chatbots. However, we want to sort of turn this maybe on its head. So question and answering can be seen as a form of knowledge graph construction, where the question is sort of, you have diabetes and you have a disorder, but then how do we construct the knowledge graph from the results which are drawn out of the language model? And if we can do this and then show this to our, say, healthcare practitioners about sort of these from our data sets are disorders of diabetes, this would be a very beneficial, and sort of removes the need for people to ask questions because they can navigate the knowledge graph, but we can sort of automate the questions which we know that they want answering. And this is seen as sort of the moonshot for us. So if we go to the next slide. So wrapping up about the three sort of classifications of data science at Elsevier, you can see that we have sort of current product, midterm and long-term objectives which we're working on, which drive data science at Elsevier. But we also have sort of side interests, and sort of I still write papers and book chapters and come and give talks. And we also put things out to the community. So we've recently, me and my line manager, have developed this open source data set, the Elsevier Open Access Corpus. This is 40,000 machine readable documents in JSON format, full text with all the references, along with about 60% of them have author-based highlights, which can be used by academics and anyone who's doing NLP research to develop new models, new systems, or develop new data sets of them, sort of annotation systems. And we came up with this because we realized that some of the data sets out there, even though they're very large, they're very focused on particular domains like the PubMed data sets or the sort of computer science data sets. And this is a complete stratified sample from across the disciplines. So if you want to use it, please go and download it and email me if you have any questions. If we go to the next one. So in summary, Elsevier is using data science today, and it's using data science to enable better outcomes for its customers. And this is not about replacing the judgment of our users, the researchers or the medical practitioners. It's about using data science to augment those judgments. And we're doing this through using ML and NLP to improve current products, but also looking at how we can develop new and innovative solutions using NLP and ML. And we're not doing this in sort of a small way. We're doing this in using technologies which can scale and expand the use of these technologies to drive impact and to drive meaningful solutions for our customers from our data. So thank you for having us, and thank you for listening to this. And yeah, do we have any questions?
Hi guys, I'm Jen Chow. I'm Director of External Engagement for the Data Science Initiative. I want to thank Brad and Daniel for their thoughts. I'll give you guys a few minutes to pop any questions in the Q&A, in the Q&A, and we can have those answered.
Hi, this is Francesca. I am just gonna get started, and we're also unfortunately running out of time. But well, first of all, Brad and Ben, thank you so much for the presentation. Then I know you mentioned and talked about it, but I'm wondering if you could elaborate a little bit about how you validate and how you when you say we want to make sure that we use the best possible machine learning model, I'm wondering how do you actually assess that? And I see also now there is also a question in the chat that you should feel free to address as well.
So we take a multifaceted approach at evaluating our machine learning models. As Brad said, we keep humans in the loop at most stages. So for the training part, we use we started using accuracy and then moved on to sort of optimizing for Rouge scores. And then once we have a model with a high Rouge score, we then do sampling across disciplines and then pass those out to our subject matter experts. We then also implement quite a few business rules on top of the outputs of models, because we realize that there are patterns which you can see which come out of the predictive models, which we know will not be good recommendations. So we look for sort of minimum thresholds of sentence lengths, maximum thresholds of sentence lengths. And all of this multi-layered approach means that we have confidence in our work as it goes out. Summarization is inherently hard to understand because they're very subjective to the individual user, depending on if you're reading it, if you're the author. So we keep this approach in and ask for, we've just had some new features go live for the online within the online tool once they've been deployed out onto the front end, where basically a user can rate each individual one and to indicate whether they like it or not. We're also looking at ways of trying to get this closer to the potential author, just so that we can get a better understanding of what they think of these systems as well. But this is sort of it's an interesting field, but it does have its challenges in evaluation.
Thank you.
So we've got a couple other questions coming in over the Q&A. This is kind of along the same lines, but or related. How transparent are the underlying algorithms utilized in systems such as those that help institutional leaders evaluate, plan, and compete? And how does Elsevier think about and work against algorithmic bias in their systems?
Yeah, I can, let me take that, and Daniel, you may have some stuff to add into this. If you go back to sort of one of the key principles around this notion of making, emphasizing augmentation as opposed to just simply automating decision and judgment without kind of recourse to explanation. We're trying to work in a way that first gets information into people's hands as part of the visualization or a report that is largely based on information we may be generating with these new data science products that, at the end of the day is really essentially highlighting features that are being extracted out of, a particular situation in the context of institutional performance, essentially, where are, sort of the hotspots in terms of, viewing information or, consumption of research content that's being produced by organizations. So, the first thing is to sort of say, look, we can add solutions in, but the idea is to present information to people for them to be in a position to make a judgment and to make a decision on the basis of that. We are, as an organization at the RELX level, which is our parent company, establishing a set of explicit ethical guidelines for the use of machine learning and AI across our products. This is something that is in formation that we plan to roll out as part of the architectural governance process in the next few months. But that is focused on achieving, essentially specifying a very explicit set of items for developers and data scientists together to examine, to establish the fact that there is no hidden bias or things that are going to skew results in a way which would increase the risk of bad decisions made on top of these things. This is early work. There's going to be a learning curve associated with this, but as an organization, we've recognized that we need to create processes that explicitly address upfront the questions of the risks that might be introduced through bias and through other manipulations of the data set that would have a negative impact on the decision making. The third thing, and then I'll stop here, is that we're very concerned in the modeling of our data to establish clear provenance for all of the items that are being generated through knowledge, from knowledge acquisition through to the deployment of solutions and creation of user experiences. So at every step of the way, we are in a position to represent where a particular enhancement or transformation has been done, what model was responsible, what source data was involved, and so forth. So that as through this human in the loop process uncovers issues associated with bias, we can trace that through to the root causes and do that, and improve our system to kind of avoid that moving forward. But it's early days, and I think as an organization, we're climbing a learning curve along with others to really understand how to operationalize the work that would allow us to establish true confidence and avoid the kinds of things that are going to skew that decision making in a negative fashion. Sorry, that was a little long-winded, but Daniel, did you have anything else?
So we try operating. So particularly for the recommender systems, we've published about how they all work. There's articles out there for people to read, along with results about how we develop them. And that sort of is, to an extent, about trying to do a bit of transparency around how these systems work. We also internally do audits about, for recommenders, it was about publisher neutrality in some of them, to look at sort of making sure for, say, for the Mendeley ones, we weren't favoring Elsevier content because that is a publisher neutral platform. For other products, we do similar auditing trails, and as Brad said, we can track down sort of issues down to root causes.
Thanks. So our next question comes from Asher Spector, and he asks, what specific new products are you most excited about? And do you think that, or will have, the biggest impact on your mission to deliver knowledge to researchers and clinicians?
You want to take a pass at that, Daniel?
For the researcher? it's sort of the moonshot idea. So the knowledge graph construction from question management systems is really interesting to work on, and that's it's fun. It's also because there's a combination between my I like looking at new technology and trying out new things. So it's a bit of self-indulgence, but I think the results in that, because a lot of knowledge graphs have been traditionally around sort of very fixed ontologies and taxonomies, it will really broaden up the knowledge graphs to say other disciplines which may not have happened in the past.
Yeah, I mean, from my perspective, I'm so heads down in building the platform out for us to do data science that the applications feel a little bit further away from that focus of enabling the data scientists and the developers to very, very quickly turn out data solutions for customer use cases much faster than we can currently. I mean, that I think will enable us to do product innovation in a much more effective fashion, where we're going to be able to cross the boundaries between life sciences, medicine, other kinds of STEM areas and disciplines. But as Daniel said, what I'm really interested in understanding is, as we gain expertise with language models and their applications to the scientific and medical literature, learning really how to treat the literature as a data source effectively, and to do that in a way which removes the sorts of constraints that today are the case with people's ability to kind of access that knowledge, to really make it possible for you to issue a structured query against the literature as a whole and get back answers that are specific and focused, that maybe relate some of the argumentational context, whether it's in support of an issue or not, whether it's a new finding, making it possible to treat the literature as a data set. I think that's an enabling thing that we're doing that I'm very excited about.
Okay, our next question comes from Jeff Popst. Hi, Jeff. Two issues that I'm concerned without regard to scientific articles are, number one, predatory journals, presumably not Elsevier journals, publishing studies that haven't undergone proper peer review. And number two, poor reporting by journalists that inaccurately reports the results or conclusions of articles. Do you know if Elsevier is using data science to address either of these issues?
Yeah, I think these are areas that we're beginning to explore. As I mentioned earlier, the issue of reproducibility and fraud are critical to making sure that as we move towards a paradigm of open science and increased share of the literature being open access, I mean, providing tooling and capability that would allow people to be able to augment their judgment across this fire hose of information that's being published. One specific example is that we've done work with image recognition to detect fraud in the sense of the reuse of imagery in biomedical journal articles, which is actually something that happens a great deal and is of concern to the editorial teams associated with that aspect of our journal publications. I think we're going to see a lot of those kind of very focused, chipping away at the problem sorts of things, and that is a thing that we're really working on within the teams.
And the last question we have is from Claudio Espesi, and they ask, how do you balance deploying tools to assist researchers with deploying tools to support senior administrators or governments? There are plenty of possible conflicts. How can researchers trust that the data will not be used in ways they do not know, or even in conflict with their interests?
I mean, that's an excellent question, and one that we grapple with in the sense that we're very aware of our responsibilities to the authors and to the researchers, and empowering them in ways that make it easier for them to do their jobs and to deliver value, through publication. And that, and we're conscious of the fact that, through processing the literature, through understanding the usage data, that we're accumulating the kind of information that, is useful to really understand what's happening in the context of the social network that researchers are collaborating in. It kind of comes back to this issue of transparency. the products that we deliver need to be something that are clearly accountable in terms of how they're flowing that data in. Can that be misused by administrators of governments, in the sense that we're providing them insight into the aggregate behavior of research communities and the like? I think as we move to an open science world, it's really going to be something that many people will have access to, the kind of raw data. What we're trying to distinguish ourselves in is deriving value out of that data and delivering it to these various constituencies in a way that where we differentiate is in the quality of the analytics, as opposed to necessarily having, in all cases, privileged access to the underlying core content. That's probably not as on point an answer as I could give if I spent a little bit more time thinking about the question. But we're very, very conscious of our responsibilities to the various constituencies. In the context of journal publication in particular, with the work that we do, with the editorial, the peer review community, as well as the authorship. I mean, there's a great deal of engagement and participation with the academic communities and the issues that they have in terms of ensuring that things are dealt with in a fair and responsible fashion. And I see ourselves again evolving as we get into these more specific kinds of data solutions as opposed to traditional content publishing. And it's something that we need to be able to manage and preserve, that kind of trust, and to build that sort of trust so that all the players in the research ecosystem are getting value in a positive way out of the work that we do as a publisher.
Yeah, we, I want to take a moment to stump for a recent project of the Data Science Initiative, which is thinking about aspects of trust in science, and the issue of cherry picking has come up as one of the things that I think the community is thinking about. How does information get used?
Yeah, and I think it's important to note that what we should be able to do is build tools for us to understand the literature and wring information out that would weigh specifically into that. The extraction of argumentation structure, the ability to sort of compare the details of the work as it is, relayed in the concepts that are being extracted is important out of these papers. I think as a data science community, with the initiative, with ourselves as an enterprise, with the partners in the initiative, I mean, this is a really important problem for us to focus on, and one that I think, in particular, this aspect that we're emphasizing of the literature as data is going to be able to advance significantly once we put our heads to that in mass.
All right. So I don't see any more questions. With that, I think I'll thank Brad and Daniel for their time. Folks, the next industry seminar is coming up on October 8th with Kershaw. We hope you'll join us. But otherwise, thank you for coming. Thank you for participating. And we look forward to seeing you again soon.
All right.
All right.
Bye-bye, everybody. Thank you.
Thank you.